So the video you're just about to watch comes from one of my online preparation courses, either the theory preparation course, or teaching in pool and classroom, or the full IDC preparation course. There's lots more information in the link below, and there's also lots more information at the end of this video. Anyway, enjoy the video. I hope you learn from it, and I certainly hope to see you again soon. Thanks. So I hope you enjoyed that last session. But now you've had some practice in working out absolute pressures in salt water in the sea, in seawater, we can now move on to questions where it's essential that you get that bit right. Now, I don't know about you, but sometimes I find PADI questions a little bit confusing. Actually, I know I'm not alone. A few years ago, I was teaching a dyslexic guy to become a PADI instructor, and he told me one day that he struggled to understand exactly what the questions were actually asking him. He often had to read and then reread questions a few times, and even when he'd gone over them a couple of times, by the time he got to the end of the question, he'd forgotten what was said at the start. Now, to be honest, as he's telling me his problems, as he's describing it to me, it all sounded really familiar to me. It's exactly what's happened to me many times before. Of course, him being dyslexic didn't help, of course, but it was clear that it's not the only cause of the problem. And I've met many people who tell me that they find PADI wording confusing. Now, my wife, she's a master instructor, and she's told me exactly the same thing. She tells me that PADI packs so much information into a question that by the time that she gets to the end of the question, she's lost track of exactly what it is that is being asked of her. So even if you don't find PADI questions confusing, even if you don't have a problem with it, you know that once you are an instructor, some of your students will definitely have a similar type of issue. So what I've done is I've devised a really useful and a simple way to help with all of this. And I call it the box method. It's got loads of benefits, including being able to jot down important parts of the question as you go along. So take a look at this YouTube video. We put it out a few years ago. Lots of people have found it really useful. And then when you've watched it, we can have another little chat about it once you're ready.
I can't do maths. I hear so often from people who are doing a dive master course, I can't do maths. And actually, I find that the people that say that, actually, they can do maths. The problem they have, though, is not doing maths, it's getting confused between two signs. And they're the two signs, the divide or multiply. And actually, once they've decided which sign to use, their mathematics are perfect. They get the sum right, but they get the answer to the question wrong because they've decided to use the wrong sign. And this actually is easy. It's nothing to do with maths. It's the easy bit. It's the bit that you know about, the diving bit. Let me try and explain. Let's imagine that you and I were going to go diving together. So here I've got the surface of the water, here I've got a shot line, and you and I are going to go diving. Now let's think about what effects of pressure are we going to notice, or that we know about. Well, first of all, I guess the first thing we're going to notice is that we need to clear our ears. The next thing we notice that our BCD would need to be equalised. We need to put some air in our BCD. And also we'll be aware that our suit is getting compressed, whether it's a dry suit or a wet suit. We know a few other things about diving as well, particularly if we're a nitrox diver. If we're a nitrox diver, we're also aware that the oxygen in the tank that we breathe is more effective the deeper we go. Actually, this applies to the effects of all gases. So if there was any carbon monoxide or some pollutant in our cylinder, the deeper we went, the more effective it would be on our body. Of course, there's something else that we know increases as well, which is density. And we also know that we breathe more underneath the water, don't we, as well? That's another thing. So, if you think about it, we know these things. We don't need to be clever. Open water divers know all this stuff. So, but here, underneath the division sign of getting things smaller, have a look at this list. Ears, BCD, suit, they're all to do with air spaces, aren't they, that are going to get smaller, or a divide sign, smaller, as we go underneath the water. Actually, I've lumped them all together with a balloon, because a balloon is like an airspace. So this is all the same type of subject. Now on this side, which is a greater symbol, a time sign, multiply oxygen, effects of gases, density and breathing. We don't need to be a mathematician, we don't need to be a physicist to know that these get greater, these get smaller, and once we've decided which is the correct sign, then I tell you what, the mathematics are easy. Now, I've got a great way to show you how to do this. I call it the box method, but the best way to explain it is to use an example of a typical question. So let's go with that, and I'll show you how to use the box method. Works every time. Here is a typical question. If a balloon has a volume of 6 litres at the surface, what would its volume be at 20 metres? Okay, now the first thing I urge you to do is get away from mathematics and just think about something you do know about. Will the balloon get bigger or smaller as you take it down? This is the crucial thing. And I think you'll know that it gets smaller, and the mathematical sign for smaller is division. So we've got that bit started. Now there's a golden rule with these boxes as well. The middle box is always going to be the absolute pressure. Okay, the absolute pressure. And in this question, the absolute pressure at 20 metres would be 3 atmospheres. So can you see, by doing the box method, I can do this piece by piece. The box over here is the number that's in the question. In other words, it has a volume of 6 litres. 6 goes in here. And now I can get my calculator out if I need to and work out the sum that I know is going to be correct. 6 divided by 3 equals... So the volume of the balloon would be 2 litres at 20 metres. Okay, let's try this with another sample question. Okay, so let's look at this, another typical question that you might find on exams. If a whole cylinder of air will last 100 minutes at the surface, how long will it last at 40 metres? So the first thing, as always, we're going to decide, will it last less or will it be longer? And we know as divers it's going to be a lot less, isn't it? Less, the sign, the mathematical sign for less, will be a divide. So the next thing we need to do is put the absolute pressure in the middle box. 40 metres, we know that to be 5 atmospheres. And here the number from the question, 100 minutes, here. 100 divided by 5, you can get your calculator out if you don't know that, and the answer would be 20. So the answer is 20 minutes, okay? So that cylinder of air will only last 20 minutes at 40 metres, and it lasts 100 at the surface. So there we go. Let's take another type of question, and we'll see the box method in use again. Okay, so another typical question, let's read it through. If a cylinder contains 0.06% of carbon monoxide, what effect would it have on a diver if it was breathed at 30 metres? Now again, we need to put on our practical head, the bit that we're good at, and we do know that the effect of that gas underneath the water would be greater than at the surface. We know that. And if it's greater, we need the mathematical sign for greater, which would be multiply. Okay, so that's the times. The next golden rule, can you remember, in the middle, we're going to put the absolute pressure, and the absolute pressure at 30 metres is 4 atmospheres. So we put 4 in here. The number here is 0.06. Okay, so we can put 0.06. And again, you might need a calculator for this one, just to make sure that the decimal points get in the right place. But the answer to the question would be... Okay, so the answer to the question is that the effect that this carbon monoxide would have on the diver at 13 metres would be 0.24%. Again, the answer. Can you see how these boxes are making it much more simpler to get these questions right? Let's have another go. Okay, so I've abbreviated the question a little bit, but I think it's quite clear. If a nitrox cylinder has got a 34% oxygen mix, what is the partial pressure of oxygen at 27 metres? Okay, so once again, we know that the deeper we go, the more effect that oxygen will have on us. So we do know that it's going to be a multiplication sign. The next thing we're going to pop in here is the absolute pressure at 27 metres is 3.7 atmospheres. And in this box here, we're going to put the number 0.34, that's the percentage of oxygen. And you definitely need a calculator for this one, I would suggest, but you put those numbers in, and I've already worked it out, it's going to be 1.258, actually nearly 1.26. And we know that the maximum level of PPO2 would be 1.4, so this diver would be quite happy to go 34% mix at 27 metres. Nice easy way to work these out. But let's take one last look at another example that you might find. Okay, so let's just take a closer look at the question. If a balloon with a volume of 6 litres, when it's at 14 metres, so the balloon's already underneath the water, what would its volume be if we took it to 22 metres? Now, you've probably heard people giving you advice before that with a question like this, they tell you to take the balloon to the surface first. And those people have given you really good advice. That's exactly what you need to do. So let's see how we can do that. In this question, we already have 2 different absolute pressures, which is why we've got 2 rows of boxes here. So the first thing I'm going to do is write down the absolute pressures. Now, the first one at 14 metres, I'm going to put here would be 2.4 atmospheres, and at 22 metres it will be 3.2 atmospheres. The other thing I already know is that the number in the question, 6 litres, I can pop in here. So we've got quite a lot of the structure already here. Now we need to remember that this balloon needs to be taken to the surface, and we do know that if it goes to the surface it's going to get bigger. So the mathematical sign that we're going to pop in here would be a times, and 6 times 2.4 would be 14.4. You can use a calculator to work that out. The 14.4 just transfers to this box here. And here now we've got to imagine that it's going to go back down underneath the water and it's going to get smaller. So the smaller mathematical sign will be here, division here. So 14.4 divided by 3.2, we're going to come up with the answer 4.5 litres. So that would be the answer to the question. The balloon, 6 litres at 14 metres, take it down to 22 metres, it will be 4.5. And once again, let's use our practical heads, the stuff that you already know about. If the balloon's already at 14 metres and we're going to take it to 22 metres, it's right, it will go from 6, it will be smaller, won't it? So if you've ended up with a larger number than 6 here, you know it's another indication you've got these 2 signs mixed up.
Okay, so that's the box method. I need to tell you about some of the comments that I received on that YouTube video. It was up for quite a long time. There was one person that felt the need to tell me that when I wrote O2 on the board, I wrote the small 2 in the wrong place. It should have been a bit lower down, I think he said, or maybe it was a bit higher up, I can't remember. Anyway, he told me. And another person told me that I didn't need to write 0.06 and call it 6%, as technically it was the same thing. So if you noticed any of my errors, please accept my apologies. But in contrast to those comments, so many other people express their thanks for helping them they use the box method to pass their theory exams. So questions relating to pressure-volume relationships are such a big part of PADI physics exams, and we'll be talking about this a little bit more in the next video. But in the meantime, I'm sure you're pleased to hear that there's some questions for you to answer in the next session, so I'll let you get on with those. Good luck with them, and I'm looking forward to seeing you again in the next video. So welcome to the full IDC preparation course. I'm really excited about this program. The reason why I'm so excited is because it's absolutely jam-packed with all of my wonderful secrets that I teach throughout my whole IDC, which is of course why it's called the full IDC preparation course. So we'll have a little look. The screen we're looking at the moment is called your course player. This is going to become really familiar to you in the next few days. But let's have a look here on the left hand side and we'll find out what's involved down here. So down here we've got our theory topics: physics, physiology, equipment, diving skills, RDP, all that stuff. We'll have a little look a little bit deeper into those in a minute, but I want to talk to you a little bit more about what's in this program. So scroll down a bit here, we've got PADI standards and procedures right up to date. You can see the very latest version based on this year's PADI instructor manual. And then when we go down here, we've got some really exciting stuff: teaching in confined water. So this is how to make your confined water teaching presentations really effective and, more importantly, really relevant to your students right from the very start. It's a very powerful way of teaching, I'm going to show you here. Perfect for the real world, of course, but it's also really good for IDCs, and it's great for PADI instructor exams as well. So loads of powerful stuff in there. And scrolling down a little bit further, right down to the bottom, teaching in the classroom. Here, I often get asked, I find people on PADI IDCs, they're really not too sure how to structure teaching in the classroom. It's easier than you think, but it needs to be entertaining. It needs to be full of relevant stuff for your students. And in here, I'll explain how all that works. So let's go right back up to the beginning again and look at these theory topics. Let's see what's in here. We'll pick physics for an example. It's always everyone's favourite, isn't it, physics? So we click on physics and we find that physics is broken down into different subjects here. We'll pick on any one of them. Let's pick on, I don't know, effects of pressure. We'll have a look at effects of pressure. And here we see there's a video playing. So it's a lesson. It's going to last for 15 minutes. It shows you here. I'm going to stop the video. So we're in control. We can stop it, start it. We can get rid of this panel on the left-hand side by clicking these two arrows up here if we want to. Bring it back again. Of course, we've always got full screen, so you can put full screen on, sit back with a cup of coffee and just listen to the whole thing. Gives you a lot more information. And then what happens also, you've got down here is complete and continue button if you want to, and that will stop the video and take you on to the next lesson. And after all of these lessons, the next lesson always is a quiz of what you've just heard, just to make sure you fully understand it. So here we've got like a question up here, very PADI type question, worded in the way that PADI would word questions. And just like PADI exams, 4 different answers that you can choose from. Find out which one is the one that you think is best suited. And just like on PADI exams, but not like on PADI exams, is if we just pick let's just pick one answer that's the wrong one and click on confirm. We find out it's the wrong answer, but not only that, not only will it tell you what the right answer is, but it will tell you why. So it will give you tips and advice where you've gone wrong to help you succeed. So all of the theory lessons are very similar to this. If we work down, loads of RDP questions, loads of diving skills and environment stuff, loads of videos on there to help you if you're not too sure of how all that stuff worked. When you've done all the theory, gone down here, what we can do then is, if you want to at this stage, go to the final mock theory exams. And here we find right up-to-date theory questions here all based on like the latest questions that PADI are asking on their exams. So here we've got PADI Theory Mock Exam A. We go all the way A, B, C, D and E, 2022 version. As you can see, all of the questions where relevant are in metric and imperial, so it's really great for anybody. Or for everybody, I should say. And then the format and the content of these exams is the same as you'll find on your final PADI IE. The wording's not the same. The wording of the questions aren't the same. That's not the objective of this. It's not to tell you what the questions are going to be. It's just so that you can understand the theory, and not only understand it, but that you can teach it to other people as well. It's another objective of this course, really. Then once you've done the mock exams, you can go to the answer key here, and you can check your answers. And clearly, if you've got some wrong, you don't understand them, or you've forgotten, you can go back to the lessons and catch yourself up again. So you can work at your own speed, your own pace, and it's fun working through it this way. Then we've got PADI standards and procedures. Again, we've got these are all based on this year's PADI instructor manual, so right bang up to date with the new programs that PADI have introduced this year. They're all in here, so you can teach yourself and work your way around the PADI instructor manual. Loads of questions. There's 50 questions, 5 exams here. Each one's got 50 questions on it. Exactly the same format, exactly the same content as the ones you'll find on your final PADI instructor exam. Once you've done those, you can have a look at your answers. You can check them with your answers. So here I've just gone to PADI Standards Mock Exam E, for example, answers. And here you can check your answers, see if you've got the right ones or not. But of course, a standard exam isn't really to do with your knowledge of standards. It's do you know where to find the standards in your instructor manual? PADI call it an open book. You can have your instructor manual with you when you take the exam, and what you really need to do is know where to find the answers in the manual. And to help you there, in this answers document, we've got all of the questions that we've asked before, but not only have we given you the correct answer, but also the page in the current instructor manual as to where you'll find the answer. So you can go back to the instructor manual and find out where to find the answer. So that's standards and theory dealt with. When we go to confined water, this is brilliant stuff here. So teaching in confined water, understanding your students. This really is good, finding out how your students learn, the psychology behind the students, or behind the way that you can teach your students. Or actually, I prefer to word it a different way. The psychology, not the way that you teach it, but the way that they learn it. So we've got like subjects on there, like on psychology, positive coaching, which is a really fantastic way of teaching people, correcting mistakes. And it gives empowerment to your students. It gives them ownership of their own learning, and it gives them empowerment as to the judge of the success is down to the student. So really it is the next thing here, student-centered training. It truly is explaining how we can make our teaching student-centered rather than instructor-centered. And when you start doing that, it's amazing how quickly students learn and how effectively they pick things up right from the beginning. Once again, this is perfect for IDCs and perfect for IEs as well. And of course, really perfect for the real world as well. Teaching in the classroom, I've already explained. It really does explain to you what we need to achieve in the classroom to get your students, in the right direction, and being able to understand and probably relate different subjects to each other. So lots more than that in the program. It's really full of fun. I'm really looking forward to working with you through this. And please, why don't you join our Facebook page? We've got the Prior Knowledge Family Facebook page. If you join that, then you can let me know how you're getting on with this program. So I'm really looking forward to the future with you. Thanks now.